Group 9, and we are doing public key, digital signatures, management, and security. Cryptography is the practice and the study of techniques for securing communication in the presence of adversaries. It's taken from Bitcoin. I'm personally going to be going over a few public key algorithms, including RSA. Before, in the past, how cryptography was used was it was a single key that each party knew, and that key was used to encrypt and decrypt the messages. But the problem behind this was that you had to meet privately to exchange the keys. So the solution was to implement an asymmetric key cryptography, which uses both a public and a private key. In 1976, Diffie-Hellman were two people, and it's not really a method of encryption and decryption, but a method of developing and exchanging shared private key over a public communications channel. Two parties agree on some common numerical values, and then each party creates a key. Mathematical transformations of the keys are exchanged, and each party can then calculate a third session key that cannot easily be derived by an attacker who knows both exchanged values. So I'm going to demonstrate RSA on the board very quickly. Basically, the first step is to generate a public and a private key. So you pick two numbers, P and Q, that are both prime. We'll pick P equals 29 and Q equals 31. Then you calculate, I'm not sure if I should go through all of this, but P times Q to find N. And so 29 times 31 is 899. Then you calculate T, which is P minus 1 and Q minus 1. I'm not really sure I should go through all of RSA unless you want me to.
Just go over the first part.
The what? The first part?
Yeah.
Okay, and then, so it would be 29 minus 1 and 31 minus 1. And you are given 840. And so then you have P equals 29, Q equals 31, N equals 899, T equals 840, and then you choose another prime number, E, which cannot be, T cannot be divisible by E, and so we'll pick 11. And you find a D, which is D times E. Mod T. So with all of these variables, the public key becomes N and E, and the private key becomes N and D. So to encrypt messages, we use the formula C equals M to the E power mod N, and C being the encrypted message. So if we took a letter W whose ASCII value is 119, it would be C equals 119 raised to the 11th power mod 899, and that equals 595. And then to reverse that, you decrypt it using formula M equals C to the D mod N, and it will give you back your original message. RSA was one of the first public keys, and it is widely used in secure data transmission. It's named after their authors, Rivest, Shamir, and Adelman. Every internet user on Earth is using some form of RSA if they connect to the internet. And its strengths rely on the hardness of prime factorization. Encryption key is public while the decryption key is kept private. This is an example of what I was just doing. You can look at it for a second. Some other public key algorithms are the knapsack algorithm. It was the first public key algorithm. Someone owns a large, and it works like this. Someone owns a large number of objects. Each object has its own unique weight. Owner encodes messages by secretly selecting a subset of objects and placing in a knapsack. Total weight of the objects and possible objects with corresponding weights in the knapsack is made public. The two major types of these are based on the difficulty of factoring large prime numbers and based on the difficulty of computing discrete logarithms. The two major types of algorithms.